everyone.
Hello.
How many of you try Uber ride this morning? This week? Only few? Okay, thank you so much for using it. Uber driver as well for the weekend. Yeah, we do have nearly on 100 models supporting you for your best experience. One single trip or one single order. So I'm Sally from Uber AI platform, and Eric is here. We are going to do the live demo for our talking about, can you do that one? Speak next slide. Yeah, we are going to be talking about it in our Michelangelo, in what is the overview of that A system, as well as that we are going to be that on open source next year. So in the past decade, Uber has that these much, like 4 major iterations, you can see that. And we have that capability of the building all these central systems that is talking about it and supporting all these classical ML, and then going into the next iteration for the deep learning model for deepen into that a more performing model. And then after that, we are doing that AI platform. And you can imagine that what is an LLM platform is that LLM platform is majorly supporting a lot of large prediction of that agents as well at the same time. And then do that one is this year is interesting. We are doing that evolving into that multi-agent platform. We are going to be that one's being planned for open source, all of them. The Michelangelo is a central Uber ML platform. It's supporting these mission critical Uber's use cases. You can think about it in marketplace when you do that, take a Uber ride. All this matching problem is being actually solved. And also recommendation problem for delivering is actually solved by that. And also we do have it in mobile ML is supporting it by Michelangelo. And recently we also do that one, it's all this kind of chatbot system to you. So Michelangelo is providing it the maximum, the developer productivity. At the same time, we are providing an ML quality. How we are doing that is best practices are all baked in. So I can talk about that as scale. And you can think about it in a scale. What is the scale at Uber? We have 25,000 models have been trained every month. And we do kind of serving all these kind of 6,000 model in reliably and scale in production systems. You can imagine that once being 30 million per second, prediction is happening at 9 digits. I can talk about that in different abstract layer. You can think about it in Uber infrastructure at the bottom. We built it, top of it, Uber's on-prem infrastructure. But after that, as you know, that once being Uber is being moving multi-cloud. And multi-cloud is actually working very well now. And open source, we offer that one is being kind of plug-in approach. Our open source partners have been supporting with this Uber infrastructure in their cloud environment as well. And top of it, you can see that core ML and GenAI is being provided. Yes, one more thing. So yeah. We have it in framework and SDK. And framework SDK is going to be supporting that in multiple cases. User can do that once being simple, and all complex pipeline is being possible through an UI base, as well as that is simple configuration base, and then SDK base. So all about it is also being part of that in open source. And the UI tool is being kind of providing a single unified interface for users, and user can track in any changes in that in their models as well as their code. So agent platform, and our engineer Jamie yesterday do kind of presentation, so you can watch it, and we do providing all this agent builder and LangFX as well as that agent studio is being provided as a whole suite. UI is being actually do best practices what we have it in successfully run at Uber. So through this kind of UI, user can do that once being seamlessly built their ML model and successfully, and monitoring is being baked in on the system. So users can do in YAML based. For example, and they configure. And a few simple configuration, they can build a classical ML model as well as a deep learning model cases. And for the simple case though, but for the cutting edge user cases, and they can do that one as being more SDK driven code, so that by this coding approaches, user can build any type of models as well. So Eric is going to do that presentation for the live demo as well. Thank you.
Thanks, Sally. So for the presentation today, I will walk you through the life cycle of how to train, develop, and deploy the model using Michelangelo. I will utilize my IDE local in my laptop and the Michelangelo UI to give you a feel of what we're offering, what we have in Michelangelo. So I will provide a bit of an overview of today's demo by splitting into two journeys. Consider there's two very common pattern journeys. I assume you're a data scientist and you start the idea to build, train, validating the model. And then also there's a ML engineer's journey about to operational, like you deploy, monitoring, and this bit of a retrain process. So let's try to put ourselves into the head of a data scientist. Right? The data scientist want to create a new project to train and validate a new idea using for example, some sort of Boston housing data set or some sort of data set he want to use. And he wanted project is a shareable and reproducible work from a scaffoldings. So this is, I'm showing you right now, is the Michelangelo list of the projects what we have. This is a list of all the projects created in Michelangelo. And currently we have a few 100,000 projects being created across Uber. So the project means in Michelangelo, it is a business use case that with a set of continuous trackable metrics. There's other project examples, something like recommending dishes in Uber Eats or ranking a restaurant on the home feed. Also, the data scientist can add any other teammate at any time to the project with a role-based access. So how we start is simply by just click the create home project page, filling out all the necessary information about your project, your description, select the tier based on the business critical, what sort of level of the business is, select ownership, and then just click submit for review. Then you will create a project for your team to review. And after your request get reviewed, then your project will be scaffolding. And here I will just go to my IDE to show a project has been previously created. So this project just simply called example project, and it just create a YAML for you. So inside this project, so everything is connected. So the data science can now instantly assess data set, feature set, and the model can be registered, and the resource can be allocated with just the same scaffoldings. So from there, now the data science can start jumping to developments. So Michelangelo comes with a pack with like pre-built trainers like attributes, deep learning, transformer models. So you can see Michelangelo offers this like collaboration baked-in features. So everyone in the same team, there's no like this is the work on my local machine disaster, or unlike a ad hoc notebook something. So Michelangelo ensure your work will start with the standardization, and it's always reproducible. And this is instant runway, just pretty much zero setup. It's just like filter some metadata, and it will give you production grade scaffolding from day one. No infrastructure friction, and just Chrome to go. Underneath the hook, Michelangelo run a very powerful workflow engine we invented inside Uber called Uniflow. Uniflow is not just another orchestrator. So it is a Python-first workflow system. It's built to unify your local environment and also production scale execution together. Here is a simple example of how people do uniflow code in Uber. So you can see this is a very simple workflow. Firstly, it starts with annotation like uniflow workflow. And this workflow only do two stuff. The first thing, it loads the data. And the second one, he just used the data to train the model. And of course, he can do more stuff. But for the demo purposes, I just do the simple stuff here. Uniflow workflow. So the data science start writing those. This is basically a Python code. And they're just adding a small annotation. Now, the data science can instantly get a distributed, resource-aware DAG that can execute anywhere. So because it's a Python code, you can just basically use in Python run, and then you are executing in the local. And this is Python. This is Python, but it's a kind of a startup Python. This is workflow can orchestrate many tasks, like I mentioned, or maybe a child workflow if you want. This is the workflow can support branching, conditions, loop, fan-in, fan-out, and retry, parameterizations. So you can write control flow in the code that Michelangelo handle this execution, scaling, lineage caching, and shareability for you. So apart from the train code, I just mentioned there's a task code. So the task code is a fundamental building block of Michelangelo's new workflow engines. It's just a new way to wrap ordinary Python function into a production-ready, distributed task that can scale transparently. Once you finish down the code, you can just start running the code. The way how we run the code is simply because we're using poetry as a Python dependency here. You can just start with the poetry run, and this will just run the script locally. For the sake of time, because this is a training code, I'm not going to do the real demo here. I just show you how we do that every daily basis. After you do local run, you say, hey, my workflow works perfectly. I want to run large scale because you know there's a limitation run everything local because your resource on laptop, you might have a GPU. You want to use a large data set and a production data set, which usually comes with a million or billion rows. You cannot do that here. Then you want to, I want to run in a real machine, in real cluster. Then you can simply just using, firstly, what you need to do is just like register your pipeline. So this register pipeline just give you say, hey, I have my pipeline ready. So this pipeline will just register in Michelangelo with all the necessary metadata. It's just telling you who registered by when, and they tell you the revision as well, because you can continue re-register the pipeline as many times you want. Every time you do it, it just gives you a separate revision. Michelangelo will make sure your code is revision, so you can always go back to any revision and replay that. And this is come with deterministic behavior because all the code can build it into a Docker images to make sure everything you can reproduce, you can debug for any purposes or backfill purposes. And you also show other relative information, something like a run, when that can trigger, from when, and some sort of manifesto about this pipeline as well. Some other information regarding the configuration, you want to set up alert and warning and some sort of trigger as well is also available. So after the pipeline get registered, the next one is just a run. So basically the run is just using MACTL tool. So I forgot to mention the tools where we had. MACTL tool is just like command line tools for the developer to interact with MA Studios. So this is something like you register, you run, and you debug. You can list all the stuff. It's just something like a Kubernetes, kubectl stuff like that. And the way how you run it is just simply just run. Run command. I just do pipeline. Sorry. So this run command is just instantly run your workflow, and then you will generate this run CRD in the Michelangelo page, and instantly you will see your run information. This is the pre-run because for the time I cannot do real run here. This tagging is different than the one I just do demo. This tagging is runtime tag. It's not compile time tag, something like other workflow orchestration. This tag is run based on your condition. So basically, the tasks showing here can be 1 or 2 or can be 10, even they come from the same workflows. So you can see this is a purely Python execute mode, right? You allow to run your entire workflow anywhere, end to end, with the exact same logic. Doesn't matter where you run locally or a remote using a full data set. So you are guaranteed you will have this thing for very quick iterations. Yep. And also, we also support some sort of predefined workflow as well. For example, we don't want to write, we don't want to write code every time. Then we have some sort of standardization for you to define a YAML format. Just, I think Sally already shared it earlier, that we provide a predefined workflow so that we have a lot of patterns that has been recognized in Uber, even across different teams, different use cases. Like, for example, people come with saying, I want to do training. Firstly, I want to fetch a data set. I want to do some transform of a feature, and then I'm going to do the training, and then I'm going to package the model, evaluation, and then deploying and monitoring. So this is a very standard. That's assume probably like 70–80% of the use cases. Then we don't want people to coding every day. So for the simplicity, we create this YAML format. People can just come ahead, change the YAML, register, and run. Simply that's it. So it's just like a one day of work. Then you will get your model trained with a good standard, and everything just get monitoring. So you can see Michelangelo offer this develop once and deploy anywhere. So it makes workflow management effortless. So it's the same code identical in different environments. So to eliminating the potential of sort of drift or logical rewrite. This also makes the model development is lining fast iterations. So change are instant reusable. So Uniflow will handle this orchestration, retries, lineage, caching, so the team can just focus on building your use cases. There's no plumbing. You don't need to worry about the environment configuring, loading, or caching file. This is something you don't need to worry. And it is the Python first experience. Engineering can pretty much just stay on the comfort zone without learning another DSL, what is the format going to look like. So that's a purely Python code. There's no extra framework you need to use. And the annotation is very lightweight. Even you encounter any error, you can always resume from a previous failure steps. So this is, and then the pipeline run page give you unified experience to track the executions, the stats, the logging, and the metric. It's basically a one-stop shop user experience. Due to these features, we can make a GenAI possible. Internally, we have an MCP server built to fetch the status from the pipeline run, and then we use LLM via agent to debug and ask people to tell what is going on and what's wrong with my code, and they can provide fix, just because it's a unified things here. This lineage also help to people to debugging from a feature, pipeline, and all the way down to model later on. So once the debugging and fine-tuning model, the data science can now have a clear successful run ready for validations. From the previous run we have, you can see this one has generated models. So this when this as soon as complete, the Michelangelo will automatically promote the output of artifact to the model registry. You don't need a manual upload, no tracking spreadsheet, stuff like that. Then you can see the model page instantly, and who generate the model by when, from what pipelines. And you will see that, and the performance, and some features and explainability as well. You can see that from the model page. And it also tracks some other information about the data quality. What's the quality of the data? I have a data quality page here. So you can see this is an example of the model with the data quality. It's telling you how good your data, how reliable your data is, like during the time when they train this model. So and the data, the model is also lineage with unlineaged and version controlled and the tag with all this information. So and then it's instant become discoverable. So people can just use it and reference for future reference. Yeah. Michelangelo also provides this built-in governance for model ownership, this report we're just showing here, the metadata tracking for free. There's no actual config. Now from here, once they got the model, the data science now is ready to launch your evaluation pipeline. So I have an evaluation pipeline showing the example here. So this example just gives you saying people, I want to evaluate my model, see how good it is. Because I'm not just like, I train the model once, then I just walk away, because you want to know how the model performs from the new fresh data every day or every week or whatever the cadence. And then you can just quickly write code. Also, we have a no-code option, like I mentioned earlier. So people can just like configure this standard evaluation pipeline. Basically mean that is, I want to evaluate this model from some sort of data set. You can specify any day range, and then you set the schedule, and we will run this evaluation by whatever the cadence you provide. So this is one of the example that's the evaluation report generated from the eval pipeline. Instantly, you will see the model metrics from the data set you generated, and you can define what sort of metric system you want to show, and what sort of data set it is. And also, Michelangelo support the way you do comparison. Basically meaning that I want to compare the newly model I generated versus for example, a production model. And they will tell you the difference between this newly generated model versus production model, and what sort of metric you want to monitor and compare with, and how good they are, and is my real new model actually better or not. So this is like building evaluation functionality for benchmarking, just keep the quality bar very high for any new model. Also, this process enables a very good confidence for autopilot later on. Basically meaning that this governance validation can be fully automated in Michelangelo, so the model will graduate from an idea to production with a zero friction and 100% transparency. So now, assuming the data science done his job, right, and he validated everything, he has sum of the model, it's good. Okay, now what the next journey we're talking about is ML engineering. They come along. They want to productionize. And then they want to productionize in a reliable way. So whatever they do, but the ML engineering focus is to be different. He just doesn't want to run the model, just run once, it's good. He need to focus on like repeatable process, scalable process, and it can do safe deployments. Now we'll talk about a bit of a retrain process. We have a retrain process example here about how people doing the retrain. So this is our standard retrain format. So basically, retrain means we can reproduce this model, use the same mechanism, but with a different data set or a bit of a different setting you define, and then run multiple times in a weekly, bi-weekly, or monthly cadence. And the model will generate with the good and then ship to production. And this is going to happen in fully automatic way. So, and then we provide a standard way to do it. You define the YAML in the retrain, define the cadence, and then firstly, the retrain will start with the data validation. Because before everything, the data need to be good. The data is everything, right? If the data is not good, don't start the retrain, don't bother, right? Alerting to the data team, fix the issue before we move on. So that's the validation is very critical here. After that, now you can start training models based on the previous pipeline we defined, we showed earlier. Then we just use the same mechanism. After that, then you will do eval. This is the same eval we're doing, but in here we just call offline experiment. This is basically an evaluation process. And when the eval is good, then we do online. What does online mean is we're connecting to a A/B testing platform. So Uber has a very powerful A/B testing platform, allow your model ship to production, only serving a small amount of traffic, so that your model, you will get confidence before the model serving 100% of the traffic. And this is just to give you a bit of an idea, more confidence about your model can really, there's no business degradations when they ship to productions. And you can specify the setting here, how long you're going to do it, what's the template configuration you want to use, and then some sort of other pipeline, how long this is the entire A/B testing you're going to do. After that, everything's good. I'm going to go deploy. I'm going to talk about deployment later on, but this is just one of the process here. Or maybe after deployment, I want to do some further verification or some triggering job, something like that. So this is a very standard return process. Because Uber, operate in a fast expanding global market. So Michelangelo was engineered in a scalability as a native compatibility here. So every project, every pipeline and model can scale seamlessly when the new market and data and the team come along. So let's go talk a little bit about this deployment, or I just touch it a little bit here. So the deployment process, what we have here, you can see the way how we deploy is very critical because we want to make sure the model can ship to production very safely. So by simply create the deployment, you will see the configuration about what deployment, what model you want to ship, what sort of type of traffic you want to serve, and some sort of legal thing here, or you want to do that to say, oh, this is my model, it need to be legal compliant or not, stuff like that. And then we support different rollout strategy. I will just show you pretty here. This is one deployment we have. So the rollout strategy is one of the most critical deployment called zonal rollout, which is provided by Uber here. This is a controlled health monitoring and incremental rollout deployment approach that will ensure safe, reliable expansion across region without any downtime. And once the deployment is finished, the Michelangelo will take over the real-time monitoring. So the platform will continue to track the latency, error rate, drift, and the model performance across the market, from San Francisco to São Paulo, giving instant visibility to the global market's health. So this is a unified observability will just help us to monitor on the feature, the systems altogether, enable the team to monitor the health for a single pane of glass. This will keep large-scale deployment stable, manageable, and always production ready. I think this is my annual presentation here. Thank you.
We have time for a couple of questions, so please, if you have one, raise your hand, and our volunteer will come with the mic.
Hi, thank you for presenting. I think that one of the slides saying that Michelangelo is a whole ML platform, so it has a lot of components. So for example, if we have something that already working feature store similar to Palette, how do we actually plug, or actually is there a capability that we can plug and play into Michelangelo when it's, for example, open source, or, I mean, there's a lot of custom thing that we have to do?
A very good question. So Michelangelo has many components, something like a control plane, data plane, and the different feature system serving deployment. They are all part of decoupled, meaning that is we define many interfaces, how we connect from one component to another component, so that we can allow us to unplug that and replug some sort of like a plugging system. Michelangelo has a very powerful plugging system that allow user to have an open source solution or connect to Uber internal solution. That's how we move fast, because we need to know people say, I have an idea, I see this product is really cool, how can we try it in Uber? Michelangelo always being asked questions like that, and that's the question we face daily. So this is a really good thing, so we being involved in the system by adopting the new plugin and the new solutions. That's how we design in this way. Yeah, thank you. That's another question. People ask questions. Yeah.
Hello? Oh, okay. It's open source, right?
Yes.
Where can we get it?
Very good question. So currently we are trying to presenting the whole thing to you, and then the thing will come out piece by piece. the entire Michelangelo will be open source. That's our goal. And currently, the first there will be component. First thing will be open source. This is the Uniflow, the project, the control plan, and then the whole entire Michelangelo probably later this year and early next year will become public. So we currently work with a lot of partners, try to validate our idea work. Doesn't matter different environment, different platform, different infrastructure. That's kind of our strategy right now. But yeah, we will have a lot more detail, and proposed architecture and more talk, and we will have a trial in the Uber's system, so to allow you to try Michelangelo in a sandbox environment very soon. Yeah.
So we just need to go to the Uber webpage and then sign up as a beta or something, or?
So yeah, Sally, you want to answer the question? Yeah.
Yeah, sorry about that, and I didn't kind of mention earlier in slide, and we do have one kind of partnership happen at the moment, and we do have successfully verified all this open source plugin approach, what you mentioned, which is Chronon versus and Uber's feature store and etc. And yeah, open source is going to be happening next year, but we are looking for that 2 to 3 partnership for collaborating within our own open source in private repo at the moment. But yeah, if you have it in a good ML platform, you want to try it out with Uber, yes, please contact us. And yeah. Yeah, sally.lee@uber.com, or yeah, I can share that those.
I will share the email address. We will share the email address with the.
Thank you so much. This was the last question. So we are going to take a quick break. Next talk will be the observability panel, but please another round of applause for the Uber Michelangelo team.